So this is question 7 for buoyancy. An iceberg, specific gravity 0.917 floats in the ocean, specific gravity 1.025. What percent of the volume of the iceberg is underwater? And B, a wooden cylinder, specific gravity of 0.4 of diameter D and length L is required to float in oil, specific gravity 0.81. Find the L over D ratio for the cylinder to float with its longitudinal axis vertical in oil. So the answer is like this. So from the question, we know the specific gravity for iceberg is 0.917 and the ocean seawater is 1.025. The SG, and then if we want to calculate the density, so we multiply with 1000 the density of water. So this is the density of iceberg and this is the density of ocean. So and then if iceberg floats in ocean, so let's say we have something like this one, so means that the force equilibrium can be written like this one, means force of buoyancy is equal to the weight of the iceberg. Both equation can be written as rho GV equal to rho GV, but you must be very careful here. So and then to calculate the force of buoyancy, so the rho GV here is the density of liquid times the gravity and the volume of the submerged area. So and then to calculate the weight of the iceberg here, so we need to use the density of the iceberg, the gravity and the volume of the iceberg. Whether it is submerged or not, we need to calculate the whole value of the iceberg. So and then because the question needs to us to calculate the percentage of volume of iceberg underwater, so we could rearrange this equation of this one. So to calculate the percentage will become volume of ocean divided by volume of iceberg times 100%, and volume of ocean is equal to 0.8946 iceberg. So we could write like this one, and then we could cancel the volume of iceberg, and then it will become 89.46%.